Hi guys, welcome back to In Case of Econ Struggles. Welcome to another Sunday Stata tip. Today I'm going to be talking about how to interpret the regression output you see in Stata. So what I've done is I've pulled in some auto data set that we've used before, and I've run a simple regression just of price on miles per gallon, weight, and whether or not a car was produced foreignly or domestically. And we are going to start from the bottom, this coefficient part of the table, and work our way up. So maybe let's just pick this foreign variable and let's think about how to interpret the foreign variable. Now, remember that when we run a regression, we are talking about correlation, not causation. So I can't say anything about being foreign causes an increase in price. We're talking about correlation. So this coefficient right here would tell me that if you take two cars, they've got the same miles per gallon, they've got the same weight, but one was produced in the US and one was not produced in the US. I would expect that car not produced in the US to be correlated with about a $3,700 difference in price, where the foreign car is about $3,700 more expensive. Now, if we go over, we see the standard error in this coefficient. If we take this coefficient and we divide it by the standard error, we're going to get the t-value. We're going to compare that t-value to about 2. If it's bigger than 2, that's going to tell us that our coefficient is statistically significant. And part of that being statistically significant is if we go over to this 95% confidence interval, we won't have 0 in there. So compare that with miles per gallon, where you see the p-value is 0.77, which is definitely not statistically significant. You go over to the confidence interval and you can see that it goes from negative to positive, so 0 is in that interval. Again, whereas foreign, 0 is not in that confidence interval. This is statistically significant and miles per gallon is not. If we go up, let's go over to this right side. Here's a number of observations, and then we have this F-test. This F-test is telling you whether or not at least one estimator in your regression is statistically significant or not. The p-value of that is 0, and we know that because we have at least one variable that is statistically significant. This does not tell you which of those coefficients are statistically significant. It just says at least one. Now we go down to this R squared. You may have heard that R squared is like a measure of fit of your model, but what exactly does that mean? Well, if we go over here to our SS table, that's sum of squares, because we have some variance in price and we're trying to explain that variation in price with variation in miles per gallon, weight, and foreign. So we have this total sum of squares. That is the total variation in price that we're trying to explain. How much of that variance did we explain? Well, we go over to our model and we see it's about half. We have about half in the residual, or half of the variation in price that is not explained, which again, if we're explaining about 50% of the variation just from eyeballing it, we would expect R squared to be about 0.5, and that's exactly what we have. Don't worry too much about adjusted R squared. The reason that you have this in here is because some people just pile in a bunch of variables, because if you pile in more and more variables, you'll make your R squared go up. But piling more and more variables doesn't always make a lot of intuitive sense. We're trying to have a good model that we think is valid. So if you start putting a bunch of junk in your regression, your adjusted R squared is going to penalize you for that. And your root MSE, again, not something you generally have to interpret on assignments. But hopefully this gives you a more in-depth look at interpreting Stata regressions. If it was helpful, make sure to like and subscribe, and we will see you next time for another Sunday Stata tip here on In Case of Econ Struggles.